We'll be starting up in a couple of minutes. You're going to want to open up your chat pod and your Q&A pod so we can send you links and you can answer questions. About one more minute. We'll get folks to finish logging in, John.
Great. Thank you, David.
I'm going to go pop my window open.
What true sign of spring? You took your jacket off.
It was just the
Wow.
best. It was just the
Oh,
best. But yes, it's a
true
little warm
sign
in
of
here right now.
spring. That's awesome. Yeah, gorgeous here in the Capital District.
Yeah, we hit 68 here yesterday in Ithaca.
Oh, beautiful. Think we were right around there. The sunshine was glorious.
Well, the bigger thing is the dry, warm weather should dry the roads out
Yep.
so they don't look like the one in the picture.
Yeah. That's right.
Okay, looks like we've stabilized in terms of who's on the call. So good morning and welcome to the last of our winter series. We'll be coming back in June. We'll have more details on that later on. My name's David Orr. I'm the director, the disembodied voice here in the background of the Local Roads Program. We're your LTAP Center for New York State. And today we're going to be talking about some common pavement maintenance techniques. We can really only touch on the subject in the hour, so we do have a workshop on that subject coming up this spring, so we'd love to see you at that. And those will be out in April and May. John will talk more about those. Our speaker today is John Rondinaro, who was with DOT for over 35 years, and I'll let John tell a little bit more about himself after we start with some polls to see who's on the call. So, Jody, go for it.
All right, good morning. The first one is my job is.
Yeah,
All
you don't
right.
give them the choice of my job is to do what the boss tells me, but
So we have a lot of engineers, some administrator. We have none of the above. If you have none of the above, if you want to put that into Q&A, let us know. And the next one is I work for. It's kind of across the board, town, county, city, village, quite a bit of state and federal. None for the weekend, though.
got one. We got one working for the
Oh,
weekend.
yes, we do. And the we have one more years in current position. So far, we have 5 to 10, 11 to 20, couple 1 to 2, couple less than a month.
Quite a variety there.
Yes. All right. And I believe those are all of our beginning
Polls.
questions.
Yep. Okay, John, it's all yours.
Excellent. Thank you, David. Thank you, Jody. Good morning, everybody. Thanks for joining us for our webinar today. We'll be talking about our common pavement maintenance techniques. Just as a little bit more background about me, as David said, 36 years with New York State DOT. I spent about 10 of them in our maintenance organization and a couple years there as the state's pavement maintenance engineer. And then for the last 15 years of my career, I served as the the department's director of materials engineering. And spent a lot of time over my career talking about pavements and in particular pavement maintenance techniques. So thanks for joining us today. Really appreciate it. And moving on. Oh, I'm not advancing. There we go. So let's take a quick look at that. That's not what we want our roads looking like. A little bit of housekeeping before we get started. We have disabled the chat. We'll use that to post any kind of handouts. We've got a handout in the chat and a couple other items that we'll put there for your use. We may be asking you to raise your hand occasionally, just as part of the interactive part of this discussion. And if you've got any questions or can't get into some of the poll questions that we ask, just put your answers into the Q&A or ask a question in the Q&A. What we'll do on the question side is we've got some natural breaks between topics. We're going to hold our questions until then. And then when we get to that break, I'll ask Amanda or Jody to just give us a quick tally of the questions, and we'll see if we can answer them quickly. If we can't answer them quickly, we'll ask you to send us an email and we'll follow up with you. In terms of PDHs, this webinar is worth 1 PDH in New York State. Only the person that's registered can get that PDH. Counts as a course, although that really doesn't matter anymore. And then in terms of other states, you're going to need to check with your LTAP center. Jumping right into it, here's a pothole on steroids. When you see something like that happen in your jurisdiction, you got to be really worried. And in this case, this is from the I-80 sinkholes that started to appear late December 2024. This was in New Jersey route again, I-80, and they spent a lot of time dealing with those through early last year. And they think they've still got a bunch of them that are going to show up because they built I-80 over a series of mines. Now, not quite as dramatic. This is how it starts. We've got a lot of cycling of snow and ice events, a lot of moisture, hitting our pavements and penetrating our pavements. This chart David provided shows your frost depths and your thaw depths. And in this case, example is Cortland County. And what you want to observe here is, or take a note of here, the blue line are your frozen, or the depth of your freeze. The tan line is the depth of your thaw. Over on your left-hand axis, that's given your inches, so or depth in inches. So you've got about a 3-inch section of pavement, about a 12-inch section of some sort of granular base or sub-base material. And if you note that we've got 2 cycles that have been tracked really clearly here. The end of November, you're free. You've got freeze, and it's going deep into your base and sub-base materials. The key here is that once that freezes, that water if it's not a well-draining base or sub-base, a well-draining granular material, whatever water is in that granular material, once it freezes, you know what happens with a cube of ice? It expands. So you've got now expanding lenses, these ice lenses that are moving, expanding the soil in all directions. Then, as you notice, note towards the end of that first cycle, or back in here we are in March, that frozen section is thawing, and as that thaws, what that void that was filled with, or that lens that was filled with ice, is now filled with water. Water is not taking up as much volume as the ice. You've now created an air void, and that's going to lead to our pothole extravaganza. We'll talk more about that in a minute. But this is just a nice example of the cycling that happens in all of our winters. So this is what's happening over time, especially at the surface. We're noticing all of the development of cracks. This is where we can end up, or worse, where those cracks greatly advance into a well-deteriorated, well-potholed pavement section. And this is kind of what it feels like. And you're dealing with a wall of water, which is one of your main, the main enemies of any kind of pavement engineer, pavement practitioner. So stepping back to the basics for a minute, what's the purpose of our roads? They're to move people and goods from point A to point B. It's the backbone of our economy. We use a process called pavement management. That's our decision-making framework. And within that framework, we inventory our roads and conditions. We then perform required work based on that inventory of roads and conditions. And the principles we follow are right repair, right place, right time. And my add to that little sequence is right way, because if you're not doing it the right way, you're throwing your money away. Quick look at the way pavements behave over time. This is a typical generic pavement deterioration curve. You start up in the upper left-hand corner. You've got a new or as new, like new pavement. Over time, it's deteriorating from high quality to poor quality, and at some point, right here down in the end, it's pretty much falling apart. And if you look at that same pavement curve, you can overlay the types or the groupings or categories of work that could and should be done for each of those condition scenarios. We're always doing our routine maintenance, things like mowing and shoulder and ditch maintenance. As that pavement is still in a good condition, we're doing what we call preventive, or what we'll be talking about today in our larger category of pavement maintenance. As it's deteriorated and now you're starting to get to the low end of good, you're going to be doing corrective maintenance. And finally, once it falls out of the good category where it's fair or poor, you're really starting in terms of rehabilitation and then moving into reconstruction. And why is that important? Well, I think probably everybody on this webinar today has seen a slide like this. For every dollar of maintenance that you spend when the pavement is in good, approaching fair condition, it's going to cost you at least 4 to 5 times as much in rehab. And some current assessments that have been done by the feds have said that can be up to 20 times, 20 times the cost of the pavement maintenance activities. So when we talk about pavement maintenance, we're really talking again about those inexpensive repairs that we're performing on good roads to keep them in good shape. The key here is you're focusing on maintaining safety, you're protecting the public's investment. Overall, you're getting the best bang for your buck. You don't want your pavements looking like this. You want them looking like this. Again, keep them like this so that they don't get to look like this. We've got a generic or a standard decision-making process, treatment selection process that we kind of use no matter what situation our pavements are in. You're going to be looking at your pavement distresses. You're going to be analyzing the cause of those distresses. You're going to be evaluating your alternatives, and you're going to come to that decision, what are the appropriate treatment options you should be considering. And when you look at this pavement, you got to ask yourself, did they make the right decision? In terms of inventorying and documenting our distresses, you've got 4 major categories. We've got cracking. Once that cracking advances to a certain point, that pavement then starts to disintegrate. We've also got, on the right-hand side, we talk about our surface defects and our surface deformations. And then in terms of the specific types within each category, you've got a whole bunch of different specific types of cracking, disintegration, surface defects, and surface deformation. Things we really need to focus on are our longitudinal transverse cracking. That advances very quickly into fatigue cracking, which means water and unloading is really starting to tear our pavement apart. Disintegration, that's when those alligator cracks have advanced to the point where the pavement is just popping out all over the place. Patching is, we note that as a distress because that's where we've temporarily fixed disintegration in potholes. Our surface defects, less common, but you will see bleeding, raveling, delaminations. And then a big one on the surface deformation side, we're always looking, tracking our rutting, because that's telling you when you see rutting associated with fatigue cracking, that means water and loading is really knocking the heck out of your pavements. And the key here is that you take this identification of the type of distress, then you're going to rate it by its extent or frequency or density, meaning how much of it is there. And you're also going to be looking at its severity again in some pretty, you can use some pretty simple ways of thinking about it. It's how much, low, medium, and high. And in terms of severity, it's how bad. A low severity, medium severity, or high severity. And then the real key here is assess the causes, because what you see on the surface doesn't necessarily tell you what's going on underneath or within the pavement section. And then on the other part of our treatment selection process, we've got the tools of the toolbox, and we've got two major groupings of our treatments. And like we're talking about today, we've got our pavement maintenance category, or our pavement maintenance treatments. Key here is we're not providing any kind of structural strength. And in that grouping, we're talking about crack repairs, we're talking about patching or area repairs, and then our thin wearing courses. On the other side, we do have to always consider, regardless of how good our pavement maintenance efforts are, all of our pavements eventually wear out. You're going to have to do pavement rehab at some point in a pavement's life. We design pavements for our asphalt pavements for a 25-year life. And if you can get in there with a really robust pavement rehab at 25 years, you can buy maybe up to 50 years. With that, we're always talking about adding structural strength, or restoring structural strength to that pavement section. And within that category, we're talking about overlays, our mill and fills, a variety of different recycling techniques, reclamation or stabilization on our low volume roads, which most of us are talking about today. And then last but not least, when you have to do it, when you've run out of options, total reconstruction. So you marry all that together, you're talking about our analysis process and evaluation process. You've married that up with our tools in the toolbox, and that brings you to your decision-making activity. But before we make that final treatment selection, we've got a fundamental question to ask and answer. And Jody, do we have a Zoom here? Or we're just going to do this with a Q&A?
We're just going to do that one with the Q&A.
Okay, so thank you, Jody. So just in the Q&A, anybody got some answers? And Jody's going to call out the first couple that we get. But before we do a pavement treatment, what's that fundamental question we need to ask and then answer? Got any answers yet? David can't answer. Anything yet, Jody?
Is good drainage, what's in our budget, what condition is the road, money, what stage is pavement at, how much do we want to spend, severity of deterioration, is it funded, and
Awesome.
cost.
Excellent. Thank you, Amanda. And I apologize, Amanda's running the Q&A and the chat portion for us. So thank you. And answer is all of the above were correct, but that fundamental question that we've got to ask and answer is, how's the drainage? And I love this picture. Dave has shared it with me. I use it in every event or session that I participate in. David was kind enough to share it. A gentleman from Saratoga shared it with us, Jay Olson. And I think it says it all. Drainage is critical for roadway design. Ducts are an indicator of poor drainage. So if you see a roadway section that looks like this, and the ducts have made a nice little resting place or playground out of it, you got to fix the water before you do anything else. And I just want to point out, we've got a pavement maintenance workbook. And we use it in our pavement maintenance workshop that we'll be conducting this year. And it's got a nice little table. David and his team developed a nice matrix that talks about the various distresses on the left-hand side and gives you your treatment options on the horizontal section on the horizontal axis, and then gives you an indication of what is could be appropriate given the different conditions. And as you can see, I've marked mine up pretty good. So to it again, we want our pavements looking like this. But one thing we want to point out is while it might look like this, you take a closer look and it's starting to look like this. And so you've really got to get your boots on the ground. You've got to take a real hard look at your pavements. Once it starts doing this, once you start seeing those hairline cracks up here, you've got to start tracking that pavement closely because they don't stay hairline cracks like that very long. They start to multiply and they start to advance or deteriorate and they start to look like this. So show of hands, who thinks this is a good pavement maintenance candidate? And Amanda or Jody, just let me know what kind of, we got, what do we say? How many people say yes?
Looks like we're at 40. We're hovering around 40.
Okay, so about a quarter, 25% of our folks think this is a maintenance candidate. We'll just hold that for a second. I would say everybody's right because a couple years ago, yeah, and based on when you got the boots on the ground, you did a real close review, you might, and in close coordination with your supplier or your contractor, you might decide you can get away with putting maintenance treatment down now, a thin wearing course, because it doesn't look like you have any drainage problems, and the pavement has good cross section, good, hasn't lost any of its shape. You might get away with it. I would argue, I think you need something a little more robust, but I could see how you could make that argument. How about this one? Show of hands, is this a good maintenance candidate? What are we looking at here, Amanda?
It's slowly climbing, but it looks like we're hovering around 20.
Okay, so yes, I think I'd agree that in this case, we've advanced too far. Yeah, really not a good maintenance candidate. You can't do any kind of crack sealing on this, and you've got an extensive enough network of cracking with a lot of secondary cracking that you've got to really be thinking of something more robust, probably at least a thin mill and fill. So, so far so good, folks. And then I think this is self-evident. This is not a maintenance candidate anymore. And while we are performing maintenance on this just to take care of the worst spots, these are all temporary measures, and we're gonna have to look at something more robust. We're into that rehab category to get this back in shape.
Hey,
So
John, you want to go
let's
back
switch
one?
gears. But before we do that, has anybody got any questions?
Yeah, John,
that we
there's a
need
question in the
answered?
Q&A for you.
Okay.
Go back to two pack pictures before.
Yeah.
I think actually one more.
Okay.
I think that's the one they're talking about. They want to know why that one's too far for crack sealing.
Yep. And the question is,
They want to know, they look like the road's lost its crown, but why was the last one beyond crack sealing?
okay, so the last one,
I think the
okay,
one we're looking
nope,
at. Nope, that
okay,
one there.
this one.
I
Well,
think so.
what you're seeing is a pretty much a spider web of cracking developed. And once you see that secondary cracking, those interconnected cracks, you're going to have what you really need to think about is what is that crack sealer going to look like once it's applied in this section? And essentially what you're going to have in here is a Ponda crack sealer. And we'll
Well,
talk
the other
about
way to
that.
look at that one, John, that's a good way. Take those parallel cracks and add them together. How wide is that? And compare that to the number you're about to show them for crack width.
Absolutely.
So go to your crack repairs and you'll see the width of, add those together, it's probably at least an inch.
Yep. Oh,
So,
easy,
yeah.
easy. So, nope, absolutely, David. Thank you. All right. Any other questions we need to tackle? All right. So let's bang through crack repairs real quick. So why do we fill and seal cracks in pavement? Well, we're filling and sealing because we need to prevent or reduce the flow of water and debris, and we've got to reduce the rate of deterioration. And so the things you've got to consider while we're doing that are your crack density, how much cracking, your deterioration, which is really your significant measure of how severe the cracking is, whether it's a nice clean vertical wall or whether it's the entire wall or top edge of that crack is all kinds of raveled and falling apart. You're looking at your width, which David just mentioned. There's once you get to a certain width, it's no longer able to to really perform well when you're putting sealant into the crack. And you've also got to think about the movement of the crack because our pavements do move with the change in temperature. We've got a nice table in the workbook. Really does a nice job of giving you a simple, nice simple way of looking at it. And what I want to point out is up in the upper left-hand corner, when you're talking about your crack density, how much versus your severity, when you're low density and low severity, you're pretty much just monitoring. You're talking about hairline cracking. Once you're into the moderate category, so anything from low to moderate density or frequency and low to moderate severity, we're talking about our crack repairs, either our filling or our sealing. And then once you fall into that high category, into the high category, if you're talking about high density and still up to moderate level of moderate severity or moderate level of edge deterioration, you're really talking about our thin wearing courses. If you're talking about high severity but low density, then you're then talking about patching. And once you get down into the high and high, you're really talking about rehab. So differentiating, what is the difference between sealing and filling? Well, crack sealing, you're dealing with working cracks. That means they're moving with the changes in temperature. So as the temperature rises, the pavement is expanding and those cracks are getting narrower. And as it gets colder, which is the real key, that pavement is contracting and those cracks are getting wider. And you're talking about, crack widths themselves of 1/4 of an inch to 3/4 of an inch. And you're looking at up to, movement defined as anything up to you change in width of 1/8 of an inch. These are considered working cracks. You've got, when you're talking about sealing, you really don't want a lot of, edge deterioration. Key here is you're using a modified and engineered material. You're putting some sort of material in it that's going to make that crack sealer behave like a rubber band. And again, you're preventing the intrusion of water and debris into the crack. Crack filling, maybe a little far, you can get a little wider, but you're really talking about non-working cracks. At DOT, we considered every crack to be a moving crack. And this is an example of a crack that you'd want to hit with your crack sealing activity. Yeah, that crack right there, nice clean edges, there's no or very little interconnected spider web cracking. You just put a nice band of you clean that out, put a nice band of material, and you're cutting off that water and debris infiltration. This one probably still can be done. There is no internet connected secondary cracking, but the edges are pretty shaky. It's starting to get pretty wide in some cases. I'd say it's right at the if you decide to seal that, this is your last chance. And then when it starts to look like this, you're well beyond your ability to crack seal. And top it off, you also see a nice deep rut that's running right along that same location. You've got indications of overloading of that, loading related fatigue issues and probably water issues. And again, way too much cracking to be able to crack seal effectively. You're turning it, that's a pond of crack sealer right there. if you tried to do it. Configurations, you've got a conventional flush fill. That's where you're just trying to inject the material into the crack itself. Overbanding, same kind of thing, only then you're leaving a significant thickness of material over the top of the crack and probably up to 4 inches wide on either side of the crack. And then this is a preferred method, a reservoir technique, where you're actually coming in, you're cutting open, you're cutting open that crack, you're creating a new, clean cut surface, and then you're injecting the material into that reservoir. This is what you don't want to see. That's where you've got that pond of crack sealer. There was a whole bunch of alligator cracking that you found underneath that. And what that's created is a huge safety hazard, because once you get a little moisture on top of that crack sealer, it's like a skating rink. In terms of your construction operations, you've got your cutting, cleaning, drying, your installation, your finishing, and blotting, while optional, is not recommended, and I don't believe anybody really does it. So in this case, you're seeing a router cutting in the crack. Here we've got the cleaning operation, and we're talking about either at a minimum, you're blowing it out with an air compressor, and or one of the preferred ways is you're actually hitting it with a heat lance, although you've got to be a lot more careful with that, because while you're drying that out, you also have you have the risk of burning your pavement. And the key, the critical nature of that cleaning and drying is, if you don't get it clean and dry, even if you're using your engineered materials, it's going to pull that material, your material is going to pull right out of that crack. Here's a conventional rig for applying crack sealing. This is what it looks like at the end of the hose. You've got your nozzle, which is injecting, and then you've got that disc right at the end of that nozzle, which is going to give you that nice thin skin of crack sealing material. Very thin thickness. It's a film, and that's going to lock that water right out. And then you're finishing it off, and probably the easiest way to do that is you're getting a squeegee from Home Depot. You're putting a V on the end, and it's gonna, knock nice little indentation at the surface of that crack sealing material, and you're gonna leave your final section looks like that. You just want to get about a fingertip depth, below the surface of the pavement at the time you're doing the work, because you want to be able to adjust. You really don't want to be squeezing that material up over the top of the surface as the pavement is expanding during as the pavement gets warmer. And then in terms of conditions for the sealing itself, you really want pretty good conditions. Temperatures 40 and above, humidity less than 80%, and no chance of rain. And now it's a perfect time of year to, starting right around now, and depending on where you are in the state, start to look at, you've got to, you can see where you can really see clearly where your cracks are, and then you can, make decisions about whether as the weather gets better, are these really where we want to be doing our crack sealing activities? Quick show of hands. How many folks out there are using crack sealing as part of the tools in the toolbox?
John,
Got about
while they're raising their hands, we have a question in the Q&A.
Sure.
It says, what pavement temperature / season for crack sealing? Cooler months when more sealer can be applied?
So that's a great question, and what you're looking for is that sweet spot. You've got to have your temperature, and when I say temperature, you really want your pavement temperature. You want your pavement temperature above 40, and you want it rising. Getting below temperature, getting below 40, not going to behave correctly. But you don't want it. You want to still hit it while those cracks are as wide as possible above 40. So spring is the perfect time to be doing your crack sealing work. So we got to show
23. Sorry, we're 23 raised hands.
Okay, so not a lot. I just, for anybody that is in the, that is a town or county highway superintendent, think about it. It might be a good tool to add to your toolbox. All right. So, quick question. What's the correct way to treat working, moving cracks? Who says crack feeling? Show of hands. Anybody? Anybody? The answer is nope. Show of hands, crack sealing. You should see every hand raise. Because
They're
you
going
need
up
to
quickly.
yeah, you need to use that. You need to use crack sealing because you're using the engineered or modified materials, which can move with the movement of the crack. You want that sealing because it behaves like a rubber band. All right. So I think any other questions on the crack sealing side?
How long should it stay above 40 and no rain?
It should stay above 40. So I would say consistently above 40. And I think at DOT, back in my maintenance days, you'd want at least a week without water. You want to give that material a chance to cure very well. No, a week before and a week after. And that was just kind of a rule of thumb. Sometimes you don't want any sort of dampness to affect that material's performance. All right.
John,
So
I'm
let's
going to chime in really quick. We do have a couple of poll questions that we went past. Do you want me to do the first couple of poll questions, or do you want to save those until the very end?
let's do those at the end.
All right.
That's great, Jody. Thank you. All right, patching. We're going to blast through this pretty quick. Except for one section. So, why do we patch? We've got a nice little community corners piece. Amanda and Jody have put this into the chat for your use. But we patch because we get potholes, and we talked about potholes are the deterioration of the cracking in our pavement. So when you look at this little diagram, you've got water infiltrating through our granular material into the soil. As that water that's collected into the underlying granular and existing soil foundation, as that freezes, it expands. Once it thaws, it melts. That is going to create, you've pushed your pavement up, maybe not cracked it, but you've pushed that pavement up with the expansion of that, as the water froze. You're creating voids now in that pavement. Once you hit it with tire loadings, any sort of vehicular loading, especially heavy loading, you're crushing. You've got those air spaces now that you've created in your granular and your soil materials and underlying soil materials. And that's, your pavement, especially thin sections, are not going to be able to bridge those holes. So that's potholes. And I think that's a nice little diagram to explain how those potholes form. So what do we do once we got the potholes? Because we know everybody is paying for potholes. Well, we've got 4 different types. The ones we really want to focus on are our demand patching and mastic, and we'll blast through real quick to get to that point. In terms of our semi-permanent area patching, that's when our asphalt plants are open. It's a pretty straightforward construction process. You want to cut out pretty square boundaries. Every time you've got a jog in your, or a change in angle, you're creating a weak spot because those are the hardest spots to compact. So really, you want a rectangular boundary. This is, while you may have saved yourself a little bit in terms of your materials, you've introduced a lot of weak points and introduced a lot more work. What you want to do, you want to square up around that distressed area. You want to get outside of it 6 to 12 inches. You want to do that because even though the surface, the edge is here, your weakened material is with 6 to 12 inches outside of that surface boundary. You want to get that boundary cut. You want to get that material removed, and there's all kinds of equipment that can be used. The only thing we want to stress is don't be going in there digging it out with a loader bucket, because you're going to be doing nothing but busting up the adjacent pavement. We want to get it cleaned out. and then you want to apply tack coat because you really need glue in between that existing pavement and that existing blacktop pavement and that new blacktop. Fill the hole. You want to make sure you got 25% extra because the rule of thumb is you're going to get a quarter inch of compaction for every inch of compacted. You want to adjust for a quarter of inch of compaction for every inch of compacted depth. You need to compact it, and you got to ask yourself, is this going to work? You see a lot of these around, but you don't want to be, you want to be careful because there's not a whole lot of compactive effort that comes out, that comes with a hand tamp, and you've got to be doing real thin lifts. If you can get in there, if your hole's big enough, you want to be using some sort of small roller, and then you finish cleaning up the patch. Spray patching is another technology. That's an all-in-one technology. Don't see a whole lot of it around New York. Some other parts of the country use it more. Really quickly, you've got either towable equipment or automated equipment. And what you do is, you've got, in this case, you've got a self-contained unit. It's got both your aggregate and your emulsion. And by changing your different controls, you're able to roll up over the top of that hole. You're going to you're going to clean out that hole. You're going to spray in your emulsion, and you're going to spray in your aggregate, and then you're going to move on. But here's what we spend a lot of time doing, and this picture is probably very familiar to anybody in the audience. We do this kind of work in the worst conditions. And why do we perform in our temporary pothole patching? We're trying to keep our pavements from looking like this. And it is a safety related issue. And one thing I want to point out here is this was using a technology, old school, called throw and go. You were using a conventional material, you put it in the patch. In this case, this is a photo David shared. I believe 2 or 3 jurisdictions hit that same set of holes with the conventional materials and hit it with a shovel a couple times, moved on, and in about 5 seconds later, that's what that hole looked like again. What we really want to be doing is using the throw and roll technique. And yeah, it's a good idea to get any of the debris or water out of the hole, but not required. Get that material, and you take a look at that material, and you can see the glossiness, you can see the shininess. This is an engineered material. You're putting additives in it that make it behave like a rubber band. You're going to hit it with a high pressure tire. The key here is that high pressure tire is what's going to be activating those additives. That's going to lock all those materials together and give it its flexibility to behave like a rubber band. There's so you've rolled over it, you've rolled back over it, you've rolled forward, you're moving on. The only thing I would say I want to do is knock those high edges down, but that patch is good to go, and that's going to last for a minimum through the season. And David and his team did a experiment a while ago. Just on your left hand side is the throw and roll technology, the simulated, and on the right hand side we're simulating the throw and go. And you can see after 26 seconds that throw and go is starting to fall apart, while you can see that through 26 seconds through 5 minutes, the throw and roll is actually self-consolidating. It's tightening up, while on the other side the throw and go is falling apart. So you definitely don't want to be wasting your money on the throw and go. So switching gears a little bit, we've got a long section of roadway with a lot of large cracks over an inch wide and high levels of deterioration, but you don't have enough money to do a rehab project. What are you going to do? And I give you a couple choices. Throw them into the Q&A. Do nothing, cry, crack seal, or something else. And Amanda or Jody, if you'd just let me know what we got.
It looks like everyone's typing their answer. We have crack seal, cry, cry, reservoir
Okay.
fill,
All
crack
right.
seal, cry. A lot of crying.
Okay, so I think we got a good flavor. Well, I got another option for you. Mastic.
It's
And
a good thing
mastic's
it's
a
not
hot
baseball,
pour.
John.
Excuse me?
It's a good thing it's not baseball.
Yeah. Um, so, so we've got material called mastic. It's a hot poured modified liquid asphalt that's got it's pre-mixed with lightweight aggregate. You can use either a coarse aggregate or a fine aggregate. You use it where you got the large cracks, very extensive alligator cracking or very severe cracks. It's got to be clean and dry, like you would be with crack sealing, but you can apply it when it's very cold, as long as you get that pavement temperature correct. It's discharged out of the back of a melter unit and it's poured directly into a hole, and either that or spread, thinly over an alligator section. And this is a technology that's continuing to be advanced and used a lot. On the DOT side, when I was there, we were using some of it, and now we're using it extensively. So here you've got a big hole, you put a nice little band of mastic over the top of it. You can use it on concrete. Here, it'll adhere to rebar, so you're fixing your approach section, part of the rehabilitation work. You're applying it out of the back of the melter. Here, you're using a nice little drag box rig, different sort of drag box rig. Hand loading it. Here's a nice little buggy that they're using to apply it. Again, you've got a nice wide crack, well cleaned, but then you're just getting a nice band of mastic in there, and that's going to hold forever. Here, you're using it in an application where you've got a lot of spider web cracking, and you're using the fine aggregate mix and spreading it out and covering it up nicely. Again, same approach. What's next with mastic? It's continuing to be developed, and it is available under the OGS standard. Apparently, not many folks in the audience were thinking about it or using it. I think this is another one you really want to get as a tool in the toolbox. All right. So getting into the home stretch, want to talk very quickly about our thin wearing courses. Got a whole bunch of techniques or technologies that we use here. Think of your thin
Questions.
wearing.
We had
Excuse
two
me?
questions from the patching section.
Okay.
So what is the material under the patching material?
Under the mastic, perhaps? Can be either asphalt or concrete, doesn't matter. Just needs to be clean and dry.
And then what is the lifespan of mastic?
That's a good question. I don't know what the current numbers are, but if I recall correctly, I think we were looking at, you were looking at, you could get it easy 5 years, depending on its application.
And then the last one, does mastic affect the friction of the pavement?
Great question. Because it comes pre-mixed with lightweight aggregate, and it's a super high friction aggregate, you're actually enhancing the friction rather than decreasing the friction. Whereas with crack seal, you don't have any aggregate. All you got is the liquid asphalt surface, and that's why you have to be careful with putting down too much crack sealer, because you do have that crack sealer is not giving you tire friction. Great question.
Thanks, John.
Oh, all set, Amanda?
We got one more snuck in. What temp is required to apply mastic?
Okay, it's kind of in the same range as as your crack sealer. You want that pavement temperature at 40, but what folks are finding is there's different ways you can get that pavement temperature up to 40. And then you can apply, as long as you get that pavement temperature up to 40. There have been some states that are applying it in some very cold conditions, but they do go through a process to get that pavement temperature up to 40.
John, it looks like it's it for now.
Okay, great. So let's get into the home stretch. We're looking at our thin wearing courses. this is what you want this is what a surface should be. When you see your surface looking like this salt and pepper look, that means water's starting to infiltrate and you need to, you want to hit it with some sort of wearing course. Think of your wearing courses as a coat of paint. And what you're doing is restoring your skid resistance, you're restoring your oxidized surface, you're sealing up that and protecting that pavement, and you can be filling minor ruts. And you got a handful of different types of thin wearing courses. You've got our chip seals and our sand seals. These are emulsion-based processes. You've got our slurry seal, which is an emulsion-based process that comes out of a self-contained unit. Microsurfacing is slurry seal on steroids, where it's an emulsion-based process that you're adding a polymer modifier to it that gives it higher elasticity and performance. NovaChip is a specialty where you're combining that emulsion-based process with a thin overlay. And then we've got our conventional thin asphalt overlays. We'll look at them all real quick. Here's a chip seal in action. What you want to think about here is you've got a nice distribution of your emulsion coming out of the liquid distributor, and then you're following up tightly with your aggregate spreader. And notice the nice brown color of that emulsion. Sand seal, same animal, but you're using a finer aggregate. Quick show of hands. When you're applying that surface-based, emulsion-based surface treatment, like a chip seal, you want that emulsion to be a deep black color prior to applying the aggregate. Yes, give me a show of hands for yes. Deep black color. What do we got, Amanda?
We going up? We're at 10, 15, hovering around, up to 20, hovering around 20.
Okay, well, I gotta disagree with the 20 of you. No, you don't want it black. What you want is a nice brown color, because what you've got with your emulsion, that emulsion is a blend of tiny droplets of asphalt that have been blended into water at high speed, and that creates a suspension which gives you that brown color, the black of the asphalt being diluted by the water. So that's how you're getting a brown color. Once you see black, that means that emulsion has broken and the water has separated from the asphalt. So you've got that suspended, you've got that emulsion suspension. It hits it bonds to, it hits your aggregate, it locks onto that aggregate, and that is when that break starts. And once you're in contact with that pavement, that water is completely separating from that aggregate, and you're no longer going to be able to bond to that. That emulsion no longer, or that asphalt no longer bonds to the aggregate. And then within a week or two, you've got what you call cure, where that water has completely evaporated, and now that asphalt film, hopefully with aggregate, in terms of your chip seal with your aggregate mixed in, is going to be over the top of your pavement. So if it looks like this, no go, that aggregate is not going to stick. And you get yourself in a situation like this, and these guys are aware of it, they're in a world of hurt. They got to figure out what they're going to do next. And it's not an easy answer. Switching gears, slurry seal, that again, you notice a nice brown color, chocolate colored look. It's a self-contained unit, mixing a fine aggregate with your emulsion, but it's a straight conventional emulsion. The advanced version of that, your slurry seal on steroids, is your microsurfacing. A lot of that being done in the state. Real great technology. And one of the nice parts about it is you can fill ruts with it. That's what the Germans used it for initially, what they invented it for, to fill ruts. Autobahn, you put a little rig at the back of your unit. You can put down a rut fill course at about 3/4 of an inch thick. Some folks will go in and do 2 courses of that, and then so that's what you're seeing on the right hand side, and then on the left hand side of this picture, you're seeing that that surface with a final surface course placed over the top of that rut fill. Nova chip is that hybrid technology used selectively around the state, but it's a nice one to keep in your toolbox. It's chip seal on steroids, and what you notice here, it's a single stone thickness, and you've got a real high, highly juiced emulsion. That brown stuff below that you see below the stone and the penny, that's what's locking in that that asphalt course, and this is true armor coating. And again, it's a pretty sophisticated technology, uses a specialized piece of equipment, and that piece of equipment, that paver, actually has a built-in spray bar that's spraying down that highly juiced emulsion, and that's what locks everything together. And then last but not least, as far as tools in the toolbox, we've got our thin 6.3 mixes. That's a bread and butter technology for DOT. But again, remember, this is a coat of paint. It's not adding any kind of structural, you're not restoring or adding structure to the pavement. And here, good paving practices are critical. And one of those paving practices is understanding whether you're working with hot mix or warm mix. I'm going to skip the show of hands. This is what, a left-hand side is the hot mix, right-hand side is the warm mix. And the difference is you're producing at a lot lower temperature. Where are we today with warm mix? If you're on a DOT or a throughway project, you're 100% warm mix. And the bottom line is warm mix is the same as hot mix. You're producing at a lower temperature, maximum 295. And one thing you really need to remember is you've got to get your breakdown rolling done before 235, or it's going to lock up on you. That makes hand work a little more difficult. And the key is here, you got to talk to your supplier and make sure you know what you're using. Getting right into the end of our presentation, what brings it all together? Your pre-project meeting. And you're talking about all the players that are getting together, what the roles and responsibilities are of each, and you're emphasizing safety. The key, you got to be planning your work. You got to be thinking what can go wrong, because it probably will go wrong. And you've got to have contingencies in place for when that plant breaks down, for when your tack truck doesn't show up, for when your emulsion, your spray bar is clogged up. You got to think about all those things and think about what you're going to do once that happens. And then once you've got your work planned and your contingencies and plans in place, you work the plan. So this is what you want. This is the process you use to get there. This is the way you can apply that process, and you can look at any kind of pavement section and apply this. Don't want your pavements looking like this. In this case, you're going to need some sort of heavy rehab, low volume. You'd probably be doing reclamation of some sort. And last but not least, what would we do here? Well, plow the snow first and then pray for spring. So recapping, roads, move goods and people, use pavement management. Our pavement maintenance, low-cost treatments, and good roads in good shape to keep them in good shape, your best bang for your buck. You've got a variety of repair options, including your crack repairs, your patching, your thin wearing courses. How do you select them? You go through that decision process. And the question you always answer first, how's the drainage? And most of all, we think safety first. So, Jody, before we talk about the workshops, we've got a minute or two, did you want to hit a Zoom question, or should we just open it up for questions, David?
John, you actually covered those Zoom questions, and you had people just put it through Q&A. So you hit every mark. We
Awesome.
don't have to go ahead and do those anymore.
Great.
You do have one question though, in the
Okay.
Q&A. It's, does driveway sealer have a benefit?
That's a great question. Yes. If you get driveway sealer on a highway pavement, no. Driveway sealer on your driveway, absolutely. You hit it every couple of years, keep the water out of your pavement section. And I've band-aided my driveway together with driveway sealer for well past what should have been its useful life. It keeps the water out.
Well, the key there, John, is to buy actual driveway sealer with asphalt in it.
Yeah, absolutely.
Because there's some out there that have, if you look carefully, essentially enamel. They're just paint. So
Yep.
make sure you
It's a
read the
very good point.
ingredients.
Very good point.
Ask for a safety data sheet when you buy it or before you buy it, and you can actually read what's in there. Look for asphalt.
Yep. Absolutely. Great point. All right, David, did you want to talk about our workshop schedule?
Well, the workshop schedule's out. We're starting up this week and going rest of the spring until highway school. And we, as you can see, have pavement maintenance at several spots around the state. The first time we're taking pavement maintenance out is in the middle of April. So get your taxes done and come out to see the pavement maintenance. We'll actually do some hands-on stuff and get a lot more details we can cover in an hour.
Excellent. Thank you, David. Jody,
Somebody
Amanda,
says they
any
have a new environmentally friendly sealer. Is it inferior? I don't know that particular sealer, the person asking the question, but it really comes down again, what's the ingredients?
you gotta have that liquid asphalt in there, otherwise it's not gonna do the trick.
Nope.
Okay, Amanda, Jody, anything else before we call it a day?
No, I think we are good to go. Thank you, John.
Thank you, Jody. Thank you, Amanda. David, any close
Nope,
points,
we're good.
remarks,
Take
thoughts?
care.
Okay, everybody, thank you. Appreciate your time today and hope to see you at the workshops.